Hi, this is Marwa, and today we have another video when we're going to talk about quadratic functions. We had a video before about quadratic functions in vertex form and one about quadratic functions in standard form. Today we will see how we actually graph quadratic functions in both forms. So let's look at our first example here. It says here graphing a quadratic function. Graph each function, and we have the function y equal negative and in parentheses x minus 1 all squared plus 4. Now, which form of a quadratic function is that? This is the vertex form, and if you don't remember or know the details of that, you need to go back to the video about vertex form. I'm going to link it for you up here. So the vertex form was f of x equals a multiplied by x minus h squared plus k. So knowing that this is the vertex form, I can find the information I have. Well, a is negative 1, h is 1 because they have the same sign, so I don't need to change anything, and k is equal to 4. How is that useful? We know that this is useful because I can say that the axis of symmetry is going to be at x equal to h, which is 1. Now let me talk you through first what we're going to do to graph so you find the rationale in what we're doing. The easiest way to graph a parabola is to find the axis of symmetry and the vertex, then take 2 points on one side of the axis of symmetry and reflect them. This is less work than anything else. Now you can't just plug in points to graph a parabola, because if its axis of symmetry is not close to 0, you can end up with only part of the parabola, which doesn't show much how it looks like. So this is why it's important to find the axis of symmetry first. Now if I know it's at x equal 1, well, here is 1, and I'm going to draw the axis of symmetry here. Now axis of symmetry should usually be a dotted line. Okay, I'm trying to make it as accurate as possible because I don't have a ruler here. So this dotted line should be your axis of symmetry, which means that the parabola is going to be looking like that or like that, depending, okay? But this is going to lie exactly in the middle of my parabola, okay? Now I can also find the vertex, which is very easy. It's h and k, so I know it's the point 1 and 4. So I'm going to use another color here, and the point 1 and 4, this is the vertex of my parabola. Now what else? I know that a is less than 0, and from the rules we took, if a is less than 0, then I know that this parabola is going to open downwards. Okay, so it's going to be looking like that definitely, and this is its vertex. Now I need at least 4 points to make this a proper graph. So how am I going to find those 4 points? We agreed that we are going to take 2 points on only one side of the parabola, either the right side or the left side. Now I would advise you to take the easier numbers, like the numbers 0 and negative 1 are easier to substitute with than the numbers 2 and 3, because this is 1. On this side I have 2 and 3, on the other side I have 0 and negative 1. So in my table, if I put 0 and negative 1, it's going to be easier to substitute for. Well, f of 0, just substitute in the equation you have, it's going to be negative 0 minus 1 squared plus 4. Well, 0 minus 1 is negative 1 squared is 1. Negative 1 plus 4 is 3. So my first point is going to be at 0 and 3. f of negative 1 is going to be negative 1 minus 1 squared plus 4. Well, this is negative 2 squared, which is 4. Negative 4 plus 4 is 0. So my second point here is at negative 1 and 0. I don't need to do any further substitution. This is more than enough. What am I going to do? I'm going to plot these 2 points first, 0 and 3. So at 0 and 3, this is my first point. And my second point is negative 1 and 0. This is my second point here. Then what? Then I'm going to use the axis of symmetry to reflect these points on the other side. Now, it has to be on the same line here, and if this is 1 unit away from the axis of symmetry, it's going to be 1 unit away from the other side, and I have another point here. This is going to be on the same line again, and if it's 2 units away from the axis of symmetry, then 2 units away on the other side, and this is my other point here. Now I have 5 points, so it should be easier to draw this parabola. Okay, Now, it's not so easy graphing using this, but I just try to make you have understanding how the problem looks like. It should be a little smoother if you're using a pencil. Okay, so what did we do? We found the axis of symmetry, vertex, then 2 points on one side of the axis of symmetry, and we reflected them. Now, this was quite easy because I had the equation in vertex form. What if it was in standard form? Well, it's not going to be any harder. We are going to use the rules we have seen in the video for standard form, and I'm going to link it for you here if you need more details. I know that this is f of x equals ax squared plus bx plus c. So a is equal to 2, b is equal to 4, and c is equal to 0. How can I find the axis of symmetry again? I'm going to use the rule x equal negative b over 2a, if you remember that. Well, it's going to be negative 4 over 2 multiplied by 2, negative 4 over 4, which is negative 1. So at negative 1 here comes my axis of symmetry. Make sure it's a dotted line because it's an imaginary line. It's not part of the graph, so do not make it a straight continuous line. Okay, then I'm going to try to find the vertex, which is the first and the most important point on the parabola. We know that negative 1 here is h. Then k will be equal to, I'm going to just substitute with h in the equation, 2 multiplied by negative 1 squared plus 4 multiplied by negative 1. Well, negative 1 squared is 1 times 2, that's 2. 2 minus 4 is going to give you negative 2. So you know that your vertex is negative 1 and negative 2. I'm going to plot the vertex. This is negative 1 and negative 2 is down here. This is the vertex of the parabola. Now we know that a is greater than 0. Then I know that this parabola is going to open upwards. Okay, I'm going to choose 2 points on one side of the axis of symmetry like we did last time. Well, the 0 and 1 are easier than negative 2 and negative 3 to substitute with. So I'm going to take 0 and 1. F of 0 is going to be 2 times 0 squared plus 4 times 0, which is 0. Now, I always like to show the steps so you don't have anything to wonder about. Still, if you feel like you have any questions, you can write them in the comments and I'll reply to your question. Now, f of 1 is equal to 2 multiplied by 1 squared plus 4 times 1. Well, 2 plus 4 is 6, so I have a point at 1 and 6. Let's plot these 2 points. So we actually did the exact same steps. Okay, the only difference is that we had to work out the axis of symmetry and vertex because we have the function in standard form. So this is my point 0 and 0, and my other point is 1 and 6, and I make them like crosses here so you get to see them. When you graph, you're going to just plot points. Now I need to reflect those points on the axis of symmetry. This is 1 unit away on the same straight line, 1 unit away. Here it is. This is 2 units away from the axis of symmetry, and there it is. Now again, take in consideration that you don't care about the y-axis. The only axis you're looking at when you graph a parabola is the axis of symmetry of the parabola that you have found the equation for, okay? Now this is that side of the parabola, and here comes the other side, and this is the graph of your parabola. It's not that accurate, but hopefully you'll make it better if you're using a pencil and paper. The steps are: find the axis of symmetry, find the vertex, 2 points on one side, then reflect them, and you have the graph of your parabola just connect. I hope this has been helpful for you, and thank you so much for watching.